All right, so in this one, we're calculating, we're not using the whole heating and cooling curve for steel. We're taking that liquid steel at 2000 degrees. So I'll put 2000 degrees in here. And you see where it kind of lines up. It's a little bit above 1538, but below that 2862. That's why those boiling point and melting points are in there. So about 2000 degrees right there. We're going to cool it down, and it's going to be liquid at 1538 degrees Celsius. And we're going to cool that liquid down until it becomes 1538 degree solid. So that's the heat of fusion there. And then we're going to cool that solid all the way down to 20 degrees Celsius. So we're going to have three calculations to do. We're going to calculate the energy needed, or the removal of the energy to get it from 2000 down to 1538, the energy needed to take that liquid and turn it into a solid, and then finally the energy needed to get it all the way down to 20 degrees Celsius in a solid form. So I have for us some of this information written down already. So there are three steps. So the first step is the delta T, the change in temperature from 2000 degree Celsius, which is our initial, down to 1538, which is our final, and that's a negative 468 degrees Celsius temperature change. And we're going to use, we're going to go Q is equal to M, which is the mass. In this case, it's 30 kilograms, otherwise known as 3,000 grams. And we're going to multiply it by our specific heat of liquid steel, which is 0.82 joules per gram for every degree Celsius. And we're going to multiply by negative 462 degrees Celsius. All right, so this is going to eventually give us a Q that's negative, which is not surprising. And then we're going to take a look over here. So what is this Q going to be? So this Q is going to be the mass of 30,000 grams, and we're going to multiply that by the heat of fusion, which is 247 joules per gram. And we're going to make this a negative number because this is the energy needed to remove in order to get our liquid into a solid. And in order to do that, we're removing energy. So that's why I'm going to put that negative sign there. If we were going from a solid to a liquid, that number would be a positive number. But I'm going down the heating cooling curve, so it's going to be a minus. And then finally, my last step is I'm going to cool down our solid. And it's going to be very similar to the step one, which is take our 30,000 grams. But this time we're going to multiply it by the specific heat of a solid of steel, which is 412 joules per gram for every degree Celsius. And we're going to multiply it by the change in temperature. In this case, we wrote our delta T over here of 1518 degrees Celsius. All right. So let's do some math here. So I'm going to multiply 30,000. We're going to multiply it by 0.82, and then finally multiply that by our negative 462. So one more time, 30,000. It's going to get a big number because of that 30,000. 0.82 times 462. It's going to be negative. So our Q ends up being 138,603,78. Way too many numbers. I'm not going to keep all of them. All right, and I got 0.84, but I'm not going to keep all of these numbers, so I'm definitely not going to put a decimal in there of 0.84. And this is going to be a removal of energy. My grams cancel out, my degrees Celsius cancel out, and I'm left with joules. And where's my decimal? sorry, no decimals. Where's my commas here? So I'm really going to pick 2 digits. And the reason why I'm going to pick 2 digits is because I was given 30 kilograms. And there's 2 digits in that 30 kilograms. You could also go with the change in temperature of negative 462. So I could go negative 13,800,000. In this case, that 6 would round up that to 13,900,000 joules, and that's a negative Q. So if you want to go 14, you can, or if in this case you want to go 13,900,000 joules. The next calculation is going to be 30,000 again, and I'm going to multiply it by negative 247. And in this case, it's going to be Q is equal to, I'm going to take this to 3 digits again, and that's what the calculator gives me. It's 7410000. So 7,410,000 joules. I see my grams cancel out. So, and this is going to be a negative number since I'm removing energy to turn it from a liquid to a solid. And then finally, I'm going to do my final calculation. And my final calculation is taking that 30,000, multiplying it by 0.412, and then multiplying it by 1518. That's going to be a negative. So get 1876. So I'm going to go 188, taking 3 digits again. So 1876 2480. So I'm going to put my commas in there, and I find I'm going to subtract out another 1,880,000. So I'm going to add these all up now. So I'm going to add up my 3 numbers. I'll circle them. So I got 13, 9, 7, 4, 1, 0, 0, 0, 0, and 1, 1, 8, 8, 1, 2, 3, 4. All right, so I get total Q equals negative 2, 3, 2, 0, 0, 0, 0. Let's see, 1, 2, 3, 4, 5 zeros. So there's my negative 23 million joules of energy needed to take our molten steel at 20 or 2000 degrees Celsius, and I've got 30,000 grams of that, all the way down to solid steel that's 20 degrees Celsius. So there is my total right there. Hopefully that helps and makes sense.